All right, we're doing the gas laws. This should be a short video lecture with short notes in there. We're just trying to understand the relationships between four variables that impact the behavior of gases. So the gas variables that we need to know are pressure, volume, and temperature. And gases are described by these properties that we can measure. And the first one, the combined gas law, deals with these three specifically. But each of the variables have a relationship with one another. So the first one, as pressure increases, volume decreases. So think about this as like if you had a balloon. Actually, I don't like this relationship as we see. So at like the amount of volume and the pressure that we experience are opposite. So at high volume, we have low pressure, and at low volume, we have high pressure. So think about if you took the gas that was in, let's say, your room, like your entire bedroom, and then you tried to shove it into like a water bottle. Well, you have all this gas that was once occupying a giant amount of space that's now increasing or in a really tiny volume. And as that happens, the pressure is going to go up. So there's an inverse relationship between these two. So saying it this way is kind of weird. As pressure increases, volume decreases, but it's more like an inverse relationship. So if I have high pressure, or if I have a high pressure, then my volume will be low, and so forth, at a constant temperature and amount of gas. Okay. So this is what Boyle's law would look like. You don't have to know this, but it's this idea that they are inversely proportional. So Charles' law describes how on a hot air balloon, as I heat up gas, that gas's volume increases. So think about with the weather, this one's really important for us because as the gas gets heated, it increases in volume, its density decreases. We get those low pressure systems with high density gas and so forth. And as temperature goes down, the volume goes down, which means you get these high density, low pressure systems that cause the rainy weather that we experience. So this is called a direct relationship. And it looks a little different. Notice this kind of set up like a proportion. There's sample problems that we could do, but we're not going to do that this year. So last one, Gay-Lussac's law. Pressure increases as temperature increases, and this is because the speed of gas particles they're going to be moving faster. So as you heat up a gas, those particles are moving faster. They make more collisions with each other in the edge of their container, which increases their pressure. Okay, which is why if you left a can of soda in your trunk or you threw a hairspray can into a fire, which please do not do that, it would explode because the pressure would build until it bursts. And again, I have a proportion to solve that one as well. So fill out this table, take a minute, just be like, okay, look at each of these, what happens between them, direct or indirect, and we're going to go over that together in a second. Okay, so what you're looking at here is pressure here and volume here. Boyle's law is the only indirect relationship, right? So if I go back to Boyle's law, it's the only indirect relationship or inverse relationship. The other two are direct, meaning as one increases, the other also increases. Okay, so in this case, you should have indirect here, direct here, and direct here, which means I should have up and up, and one is up, one is down here for those tables. So indirect, direct, direct, up, and down. So this results in the combined gas law. One of the variables is usually held constant, which means you could remove it from the equation. And the subscripts, the ones or twos, those indicate the initial or final conditions. So if I increase temperature from 10 degrees Celsius to 20, what would that do to my pressure? My pressure would also increase or double in that case, because there's a proportional direct relationship. And usually you can remove one of these from that case. So an example, I have a can of hairspray. the volume is constant, right? Because the size of the can doesn't change. So if I increase the temp, what's going to happen to pressure in there? The pressure will increase. Pressure will increase. Okay. There's another gas law that we'll talk about a little bit today. It's called the ideal gas law. It brings in a fourth variable, which is N, or number of moles. And this represents gases really well under specific ideal conditions. So it takes Boyle's law, Charles' law, and Gay-Lussac's law, and combines it with Avogadro's law relating volume to the moles of gas. So under these basic gas laws, we have four different variables, P, V, T, and N, and they can be combined into one equation called the ideal gas law equation. This one's really useful because now I can solve for the amount of molecules in that gas, which is significantly important. So it's this equation right here. It's called Pervnert. You got pressure, volume, number of moles, R, which is just a constant, and temperature. And the R value, it depends on how you're measuring the pressure. So that's why it's important that we understand the different types. Volume is always in liters and temperature is always in Kelvin in that equation. So one thing to know about the ideal gas law is no gas perfectly obeys all four laws under all conditions, meaning the Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. So we have to make some assumptions in order for that to happen. So the gas isn't going to condense to a liquid, which is obviously false. At some temperature, the gas would become liquid, and there's no forces between the molecules themselves, either bouncing off one another or attracting or repulsing one another. The particles themselves take up no space, which we know is not true. Even if an atom is mostly empty space between the nucleus and electrons, we know that atom still has volume. But those assumptions work well for most gases under most conditions. So we'll assume that all gases fit. And the last thing we have is this fits quite well at STP, which is at 1 atmosphere and 0 degrees Celsius. Okay, so really the only thing that you have to know about these gas laws is the relationships between pressure, volume, temperature, and amount of gas. Be like, well, if I double the gas, what's that going to do to my pressure? Well, I have way more particles now, so my pressure is going to go up. If my pressure goes up, what's that going to do to my volume, and so forth? So make sure that you understand those relationships.